Yeah, just a minute. I actually forgot to create the attendance. Let me just do that. Yes, I have created the attendance form. Let me just send it. Let me just forward it actually. Okay, done. So please mark your attendance now. So I have 49 attendance responses and only 39 people are here. Anyhow, let's wait for maybe 1 more minute. Okay, so I don't think I should actually wait for the numbers getting to 50. It's becoming kind of sub 50 range lectures these days. Okay, we might reach 50. uh, Okay, anyhow, so I guess that should probably be it. We can start now. Okay, so what in this week we've been actually looking at polymorphism and the different forms of polymorphism that you might see in C++. In the first lecture, we actually had an idea of what exactly is polymorphism. Then in the second lecture, we had a look at a particular type of polymorphism called overriding. And now in this particular lecture, we are going to have a look at another kind of polymorphism. The name of this is overloading. Okay, so okay, we've hit 50. So overloading and overriding, they are two different terms. So in this lecture, we are going to have a look at overloading. Before that, any questions from the previous days? Okay, let's start with overloading then. Mm, okay, Mm, just a minute. Let me put it here. Okay, so we've discussed constructors, right? I mean, you guys have already seen that. What exactly were constructors? Constructors are basically a specific type of method that we define in a class in order to initialize objects, right? So we also saw that there are at least three types of constructors that are there. I mean, not at least there are. These are the three types of the constructors. The default constructor is basically the constructor which takes no arguments whatsoever, right? So basically, this is the kind of constructor where you don't seek anything as argument when the object is created, when a new object is created, and you are not passing any arguments as such for initialization. Then whatever you do in a default fashion, that is basically the default constructor. And you must be remembering that if you do not provide a default constructor, the compiler provides one for you. Similarly, the most commonly used constructor that we often make use of is the parameterized constructor, where we pass one or more parameters arguments to this constructor. Usually these any questions? Okay. So usually these arguments have a one-to-one relationship with the fields of the class, right? So let us say in many cases, if I have, for example, three fields in my class, I create a three argument constructor, and these three arguments are assigned to the three different fields. This is a common practice. It is not necessary, but it is a common practice. You can of course say that I don't need three arguments. I only need two arguments, and I'll give one default value to the third field. So that all these combinations are possible. The third type of constructor was a copy constructor. So I told you that this constructor is called whenever the compiler is supposed to make a copy of your object. Typical examples are when you pass an object by value to a function, or you return an object from a function by value. You need to copy the fields of a particular object. So in such cases, a copy constructor is called. Again, if you do not provide a copy constructor, one is added for you by the compiler by default. Now, one aspect that you already know then is that a particular class can have more than one constructors. Right? This is clear. We have seen that it is possible to do that, including both defined as well as those added by the compiler implicitly. And which constructor is invoked, that depends on how you are writing that statement of creating the object, right? If you are simply saying class name space object and then the semicolon, then you are basically saying please invoke the default constructor for me and initialize this object. If you write something like class name space object then in parenthesis some values, then you are basically asking the compiler to figure out which particular constructor is it, if there are more than one parameterized constructor. Or the idea is that you basically match my requirements. These are my requirements, and on the basis of this there will be some constructor in the class, so please use that one. So overall, the way you call that constructor, okay, the arguments and everything, they decide which particular invocation, which particular definition from your class is to be invoked, right? So in one way, what we are really trying to do is, for different scenarios, we want our object to be initialized in a different fashion, right? Sometimes just uh, 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 just initializing all the fields with the default values is fine. Sometimes I may want specific values to be assigned to specific fields explicitly, and for such conditions I write a parameterized constructor. So the overall idea is that you want to basically do the same thing, but based on the scenarios you are going to do it differently, right? So this is the overall idea of polymorphism, that it is the same behavior, but you are trying to do it in different fashions in different scenarios. So that is basically polymorphism, at from 30,000 feet. So overloading is another example of polymorphism. What you do is you basically define multiple versions of the single function, and based on scenarios, and here scenarios essentially mean the way you are trying to call that function. Based on that, the implementation is able to figure out which of these multiple definitions are you interested in invoking. So the concept of overloading a method is basically, you can, at the level, at the conceptual level, you can basically consider that it is like there is some behavior of a class, and this behavior can can be slightly different for different scenarios. It is exactly the, again, conceptually it is not different behaviors, okay? It is basically the same behavior, but you can consider it, there is a kind of if else situation, that if the scenario is this, do this, else if the scenario is this, do this. So if you have something like this, it's the same behavior, but it might differ slightly for different situations, then you use the concept of overloading, okay? So basically you provide two or more function definitions for the same function, okay? So it is the same function, and when I say the same function, what I really mean is two methods are considered to be overloaded versions of each other if the name of the method is same in both these definitions and the parameter list is different. See, so keep in mind that if the name is also is the same as well as the parameter list is the same, then the compiler is going to raise an alarm, okay? It will not tolerate this. So the parameter list has to be changed. That is the idea. The return type doesn't matter, okay? So if you feel that if you create two definitions of this function, where the parameter list is the same, the name of the method is same, but the return type is different. No, that is not allowed. That the compiler will not let you go through with. So you have to make a change in the parameter list, and then the compiler will let you go away with it. Okay, it will allow you to have as many versions of this particular method as you wish to. So this is an example. The overloaded constructors that you guys have already seen, two constructors in the same class, but what really is differing here is the argument list. So in this case, it is taking string and int as two arguments, and here is it is taking a reference to the toy2 object. So basically, it is the same method. You can see the name of the method is the same, which is essentially the name of the class. But since the parameter list is different, you are allowed to do this. If you try to create another constructor with the same parameters, string and int, the compiler will raise an issue. It will not let you do that. So, as I said, overloading is basically useful whenever the behavior of a class differs with respect to different scenarios. Please keep this in mind that this is different from overriding. Okay. So in overriding, what is it that you have? You have an inheritance hierarchy. There are multiple classes involved. You say that this behavior with respect to class A is this, and this behavior with respect to class B is something else, right? So basically, the changes are across the classes. It is not within the same class. Okay. So, but if you have different forms of the same behavior within the same class, then that is an example of overloading. Okay. So please don't get confused between overloading and overriding. Overriding is something that is completely different. Okay. And overloading in general, whenever you hear the word overloading, not just in C++, but this term is a very common term in object oriented programming. So whenever you usually hear the term overloading, if the person is not saying anything else, you should consider it as method overloading or function overloading, right? There is another type of overloading, by the way, called operator overloading. It is not there in many languages. In fact, if out of the languages that I have worked in throughout my life, it is only in C++. There might be a few other languages in which it is available, but C++ is the main language where operator overloading is provided as a feature. Many other languages which have object oriented programming support, they do not let you do operator overloading, and there are reasons for it. Operator overloading is not a very good concept at the level of design, right? So we'll discuss the demerits towards the end, but the idea is, whenever someone says overloaded or overloading, by default you should understand it to be method or function overloading. So just something from our toy domain, which we have been trying to use for a long time. So let us say that you now want a toy demonstrator. Okay, a demonstrator is basically a person who's going to demonstrate, person or robot or whatever it is, who's going to actually show the demo for any given toy. That how exactly do you play with this particular toy. Okay, so let's say I have a class called toy demonstrator, which is essentially representing a demonstrator of any toy. And what I really want to do is I want to I want to pass this class a toy, and then this class simply calls up the start playing and stop playing methods. So these toy classes have these methods: start playing and stop playing. So all this demo is going to do is it is going to do the start playing and then the stop playing part. So this particular class has two methods, show underscore demo, but you can see that they are not really two methods. Okay, they are basically the overloaded versions of each other. The first one is taking an object of type toy2. The second one is taking an object of battery operated toy. Why? Because this is the issue that if you want to show the demo of any toy that is going to have a battery, ideally you should put in the cell, the batteries, and then show it. I know most of the Indian shops, they don't do that, but in many places you would see that if the toy is battery operated, the shopkeeper will have some kind of a common batteries available in the drawer, and that person will take out the batteries, put it in the toy, show you how the toy works, and then if you are satisfied, you can buy the toy. So the same idea is here, that for a battery operated toy, you also need to provide the type of the batteries and the number of batteries that are there. So that is there. There are two versions. This one is the generic version. It is applicable to all the toys, and this one is, I have created a specific one just for the battery operated toys. And in fact, you can see that in the second version, I do actually call the first version. Okay, so this is also very common. Whenever you overload methods within a class, these overloaded methods, as I said, that they are in most cases they should be the same behavior, but you want to do something slightly different in a slightly different scenario. So it is again just like the overridden versions, where it is common to invoke the super class or base class versions. In overloading also, it is common to invoke each other. The overloaded versions often invoke each other, and this is what we are doing. That basically, for a generic toy, I simply call the start playing and then stop playing methods. For the battery operated toys, I first put the batteries, show the demo by calling this method, and then I take out the batteries. Okay, just it is just like uh, it's a way to show you how things work in the real world. That is the idea. And when you want to call these methods, this is how you do that. Basically, if you call it with just one parameter, and that parameter's type is t, the implementation will be able to figure out that you are calling the first version of the definition. And when you pass it three parameters like this, the implementation will be able to figure out it is the second form of the definition. Okay, and of course, it is certainly possible. But so what really happens is the compiler tries its best based on the parameters that you have passed to match this to a provided definition. Okay, but it is certainly possible, and it really does its best job, right? It will even do implicit data conversions if required. So for example, in your defined function, you are, let us say, taking a long, but here when you called it, you passed it an int. So by default, the compiler will implicitly convert the int to long and then call the long version. I'm just like giving you an example. So the compiler tries its best to find out a definition which can be applied to the call that you've made. But at the end of the day, it is possible that the compiler may not be able to find a relevant definition, in which case you are probable to see a compilation error, where where the error will be something like, I cannot find a matching definition for this expression in your code. So it is common, many a times due to mistakes, it is common that you get these kind of errors where the compiler is not able to find a overloaded definition for a particular function, for a particular method. But in most cases, it works like a charm. So any questions till now? So let me again summarize it. The idea is that you have one particular behavior of a class, but this behavior may be slightly different. Usually, I say slightly different because I'm trying to convey that these are not two different behaviors. They are just two different versions of the same behavior of a class, and based on different scenarios, you want different versions of this class, of this method to be invoked. So in this case, you use the concept of overloading, that you overload that particular method, and then you let the implementation decide which definition is applicable to which calls. Okay, and another point is, the return type doesn't matter. Okay, it's only the name of the function and the parameter list. The return type is never counted, whether it is the same, whether it is different, doesn't matter. Okay, if you want to overload a method, you have to change the parameter list. The By changing the return type, it is not considered as overloading. Any queries? Okay, So now the other form of overloading that I talked about is operator overloading. Now, to give you an example of where something like operator overloading probably makes sense, this is in fact one of the few examples that I could actually find. Even though this is a very what can I say, very old and dated example, but for operator overloading, I don't think there is any example which is better than this one. So assume that you have a class for complex numbers, okay, to represent complex numbers. So typically in a complex number class, you will have two fields, one to store the real part of your number, and the other one to store the imaginary part. Now, let us say you have two objects of this type, C1 and C2, and then you want to add them together. Okay. So what are the things that you can do here, right? What can you do to add two complex numbers? So one way to do that is by implementing it as functions, right? So it could be member functions or global functions, friend functions, whatever it is. But the idea is you basically do it using some kind of methods. So typical kind of expressions that I'm talking about is something like this. You have C1 and C2. So you create a member function called add, and when you say C1 dot add C2, this is equivalent to saying C1 plus C2, and this method returns a type of complex again, so you can catch it in, let us say, C3. Similarly, another way to do that, if you don't want to make add as a member function of the class, then you can create it as a global function of the class, and provided that whether you want access to the private members or not, this could be friend or a non-friend function, whatever it is, but this is basically a global function, and you pass it two arguments, C1 and C2, and the result that this particular method returns is essentially C1 plus C2, right? So this is fairly clear. Now, there are some people who feel that this is not acceptable because C1 and C2 are both numbers. I should be able to write something like this: complex C3 equals C1 plus C2. Okay, so and there is no doubt that this actually does look better, right? I mean, this is very easy to read. It is more, what can I say, natural for human beings to read stuff like this. It's very, the semantics of this expression is extremely clear. I know these are two complex numbers, and this is the sign for plus. So if I just put a plus between these two complex numbers, it should be addition. So everything is nice in this example, right? So is it possible to do something like this? Well, yes, in C++ it is possible. You can do that by overloading the plus operator. That is the idea, that we are not overloading a method, we are basically overloading an operator. Okay, and this operator here is the plus operator. So by default, this plus operator is not defined in C++ for objects, but that is what operator overloading can do. You can define an operator for a particular class, for the objects of a particular class, in such a way that you can write expressions like this. Okay, so this is possible in C++. So as I said, right, so overloading the operator basically means you're going to provide or change. It is there, right? So you either provide or you change the definition of a definition for of a particular expression in C++, and this expression essentially contains the operator and operands of that particular type. So if we are discussing the complex class, then basically the operands are complex objects, and the operator is, let us say, plus or minus or something like this. So you provide a new definition, okay, for it, and you say, okay, this is how we if whenever you find the expression C1 plus C2, please interpret it like this, and this is the whole concept of operator overloading. So here is one example. Let us say you have these three toys, and you can see something like this here. T1 is greater than T2 is greater than T3, or T1 is less than T2 is less than T3. Now you understand that this I mean, straight away it doesn't make any sense, right? what is this greater than and less than operators doing here, right? This is because what we have really done is we have overloaded these operators for the toy 3 class. Okay, so what and what, how are we interpreting this? So we define that greater than operator, and this is defined by us. Okay, it is not defined in mathematics, it is not defined in this is not defined by C++ language. This is defined by us, that this greater than operator, when used with the with toy objects, should be interpreted as the costly operator. So what it really means is, if you give it two operands, so t1 greater than t2, what it will basically do is, whichever is costlier, whichever of the two toys is costlier, the operator returns that as the output in some ways, right? So basically, in this particular case, when I write t1 greater than t2 greater than t3, what I really want to do is, I want this to be executed like this: t1 is greater than t2, so whichever is bigger out of t1 and t2, that is returned here, and then the result is greater than t3. So whichever, so the net result is, I actually get the most costliest toys out of t1, t2, and t3. Similarly, I define this less than operator as the cheap operator. So basically, it is doing the exact opposite, that I want to know which out of the two operands is cheaper, which of the two toys is cheaper. So T1 less than T2 less than T3 essentially means which out of these three is the cheapest toy. So you can already see that this is pretty random, right? I mean, I decided to have this kind of interpretation of greater than and less than sign, and that is why I can only explain it to you. Unless I explain it to you, it is really hard to figure out what exactly do these expressions mean. And this, as we'll talk about in the end, is the major issue with operator overloading. But because it is a part of C++ and I just wanted to show you a simple example, I have shown you these two overloaded operators, and the way you actually provide the new definition. So you have to tell me, right, what should the compiler do whenever someone writes t1 greater than t2 or t2 greater than t1, whatever it is, right? So I have to write some code here, right? I have to tell the compiler, whenever something like this happens, please invoke this piece of code. So I can do this using two ways. Okay. First way to do that is that you provide this definition, this code, as a member function of that particular class. So you're defining it, for example, for the toy class. So you make it the toy 3 class. So you make a member for you make the definition a member function of this toy 3 class itself. The other way to do that is by creating a global function and making it the friend of this particular class, right? So now, how exactly are these two variants different from each other? So it is similar to calling c1 dot add c2 and add c1 comma c2. Okay. By the way, this I have already said that operator overloading is a very complex topic. There are so many ifs and buts, and how to, for example, how to provide a version for pre-increment operator and post-increment operator, because that is another issue, right? The plus plus operator. If you put it after the operand, it has a different meaning. If you put it before the operand, it has a different meaning, right? You all are aware of those scriptive output questions, where you do something like I plus 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 j plus plus kind of things. So it's a very complex topic, operator overloading, how to do operator overloading for different types of scenarios. There are certain operators which, if I'm not wrong, cannot be overloaded. There's a list, by the way, right? I mean, there's a whole bunch of text associated with operator overloading in C++. It's just that I do not really want you guys to to dive into that pond. Okay, that because to the west of my knowledge, there is really nothing that can be done only with operator overloading. Operator overloading is more of a cheesy way to do the same thing. Okay, you could do it in a much cleaner way by implementing it as a method. but because it's a language feature, we are just studying it anyhow. So the reason we have these two ways to define this operator overloading code is because if you put it as a member function of one class, um, often what really happens is you want to use member function of a particular class as definition of an operator for another class. Okay, it's a very complex scenario, but it is possible. Sometimes it is required that that the function where you have provided the definition is essentially a member function of another class. So in such cases, it is better to, I mean, not better, the only way out is to make it a friend of this another class or whatever it is. But in most cases, it is not a bad idea to implement it as a member function of the same class, because it keeps the code together. Wherever is the class defined, the members of the class are defined, you can just put the definition there. It is a good idea. So anyhow, the way you provide these definitions is something like this. The name of the function where all this definition is given is basically the keyword operator and followed by the actual operator. So this is the example that here the I'm uh, overloading the less than operator. So the name of the function here, okay, is operator, and then the actual operator that you are trying to overload. Now, so as I said, if there are two variants, right? One variant is where you create it as a member function of the class. So then you only need and by the way, we are having all this discussion for a binary operator. It could be for a unary operator as well. I don't know whether they allow that ternary operator to be overloaded. I really don't know, but you'll have to go and check out the operator overloading text. I'm not really a fan of operator overloading, so I never really uh, you know dug deep in the literature for that. But yeah, by the way, whenever we are talking about an operator, we are talking about some binary operator. It is possible to overload unary operators as well, but let us say we are talking about a binary operator. So in that case, whenever the function is provided as a member function of the class, you only need to pass one parameter, right? Because the other parameter is essentially the same object with whose member function is going to be called. So going back to our complex number analogy, if the addition function, the addition definition, is added to the class complex as a member function, then whenever you write c1 plus c2, this is in some ways equivalent to writing c1 dot add. So add is essentially that function which is implementing the addition logic. So it is equivalent to writing c1 dot add c2. So you only need to provide c2 as the parameter. You don't need c1, because c1 in some ways is implicitly available to you. Okay, and whenever you write it as a friend function, then you have to write it like this. You have to pass both the parameters, both of the objects as parameters to the function, because as this is equivalent to writing add, which is a global function, and c1 comma c2. Is this part clear? Why is it that you need one less parameter in case of a member function as compared to a friend function? It's not too difficult to understand, but sometimes people can get confused. Why is it that the member function is taking one less parameter? So is this part clear? Because you don't need one parameter is provided to you implicitly. So what you really need is only the other parameter. So is this part clear? Any queries on this?
So for member functions, operator
Mhm.
functions, it's the left side operand that is
Yes.
passed implicitly.
Yes. It is the left sign. So basically, if you write c1 plus c2, the first operand is used to invoke the method function, the member function, and the second one gets passed to it as an argument.
And so what if the operator is used in such a way that the first operand is of another type and it's the second one that is
Yes. So in that case, yeah. So basically, this is one of the problems with operator overloading. So let us say you want to have a scenario where you want to add an integer to an object. Okay. Let us just assume that there is some scenario. Okay, in fact, let us consider the same complex number scenario, that what you want to do is, what you want to write is something like c1 plus 5. Okay, because 5, we all know in mathematics, if I just write 5, it basically means 5 plus 0 I, right? I mean, the imaginary part is 0. But in terms of programming, if I write c1 plus 5, then it doesn't make sense, right? On the left side you have an object, on the right side of the plus operator you have a number. But you can do this using operator overloading. So there is you can actually provide overloaded definitions of this operator as well, right? So it's like you can do function overloading as well as operator overloading, right? So in function overloading or method overloading, it is the same behavior. What changes is the parameter list. So the same thing can be done with operator overloading as well, that basically it is the same operator that you are overloading, but based on the second parameter, it could be the same as the object, it could be something else. You can define overloaded forms of this overloaded operator. Okay, but again, let me give you the problem with this. In this case, you can write a definition where the argument is int instead of complex. The second argument is int instead of complex. But it will cater to cases like c1 plus 5, but the moment you write 5 plus c1, it will fail. Okay, so that is the idea. The member function form has certain limitations, that it can only cater to c1 plus 5, but if you write 5 plus c1, that cannot be catered to by using your so you will get an error. For example, the compiler will simply say, I don't know how to interpret it, 5 plus c1, if the add part is implemented as a member function. And that is why in many cases, whenever you have such a kind of scenario, that one of the two parameters could be of a different type, so in such a kind of scenarios you can define two friend functions. Okay, one which takes the first input as int and the second as complex, and the second one where the first one is complex and the second one is integer. So with friend functions it is possible, the compiler will simply try to match your arguments and their order with the definitions, and then you can have two different friend functions, and catch both c1 plus 5 as well as 5 plus c1. Is this part clear?
Yes, thank you.
Okay, so yeah, that is I mean, let me be very honest, I'm not a fan of operator overloading. I didn't even want to teach it in the class, but it's kind of teaching c++ without teaching operator overloading is kind of incomplete. So you must know, even if I strongly suggest that you never use it, I'm still telling you what operator overloading is. So anyhow, yeah, and by the way, usually in order to avoid creation of new objects, because you understand that whenever you write functions which are passing parameters or returning parameters via value and not reference, a copy of the object will be created every time, right? So to avoid creation of new objects, we usually, again, it is not a necessity, but we usually pass the objects as well as return the objects by reference. So this is an example of that greater than operator which I have overloaded for toy 3. And the only thing I'm doing here is I'm just comparing the two prices. Okay, the prices of the current toy as in the implicit object which is not provided to the method, because you are doing something like, as I said, c1 dot add. So in this case it is the c1 part. So so you are basically comparing the get price with that of the other object that you have been passed. Okay, the so here in this way, if you say t1, if you write t1 greater than t2, what is really happening here is t1 dot get price is essentially get price, and other toy dot get price is essentially t2 dot get price. Is this part clear? I mean, I know it's not good to use operator overloading because it could be very confusing. But can you at least try to understand what is here? What is happening here? There are two toy objects T1 and T2. I have put the operator in between them. As we just discussed, in this case, the first operand is used to call this member function. So what is really happening is T1 dot this member function is being called. So within this member function, this get price is essentially the get price associated with T1, and this get price is associated with T2. That is the idea. Okay, any questions? Okay, and then this is the other form, the friend function form. So here you are passing both the parameters. Okay, so if you write T1 less than T2, for example, T1 will become first toy and T2 will become the second toy. And then just some comparisons between the prices, and I'm just returning the result. So this is what I was saying in the beginning, that keep this in mind, that overloading operators, whatever you do with overloaded operators, can of course be done by an appropriately named member function or a friend function. So in fact, take this as an example. I wrote T3 equal to T1 less than T2. If instead of writing this, I had created a friend function called cheaper of the two, and I had provided the two toys as inputs to it, T1 and T2, which of these two seem to be more readable, right? To me, the second one is more readable. If the name of your function is well thought out, as anyone who simply reads this line, T3 equal to cheaper of the two, T1 comma T2, will understand roughly what this method would be doing. But if I just write T1 less than T2, I have to explicitly write that here the less than operator is basically going to select the cheaper of the two toys. Okay, and this is the major issue with operator overloading, unless you are doing it for a very specific case where the semantic of that particular operator is obvious, right? In, let us say, for the example of complex numbers, the semantics is obvious. Even for strings, okay, even for strings where this plus operator is overloaded, a person who's new to programming might not be able to understand what does it mean by when you write string a plus string b, whatever it is, right? You'll have to tell that person that, okay, plus here basically means concatenation, right? That is the interpretation of plus with respect to string. But so even overloaded plus operator might not be something that is very natural. But over a period of time, the programming community has become accustomed to seeing concatenation in the form of plus. So that is why most of the languages provide you this option to simply concatenate the strings using plus. But as I said, it's still probably unnatural. So the same thing is here, that whenever you are going to create any operator within an operator, whenever you are going to create a definition for any operator for a particular class, please keep this in mind, that you are doing the right thing. Okay, you are not actually complicating the stuff for yourself. You are not making the code hard to read or hard to understand. Okay, so that is it on overloading. Any queries? No questions?
Sir, could we define an overloading uh, which does not compare the same type of objects?
Yes, that is what we basically said, that the example of C1 plus 5 is such an example, that when you are where you are trying to overload the
Yes, sir.
plus operator, but the operands are different. Okay, then there are some ifs and buts associated with it, right? So for example, if you are putting it as a member function, the way you to do that will be, instead of let me go back here. So instead of this parameter being toy3, it will become int, for example. If it is complex, this will become int. So you are now defining it for complex number and an integer, and then whatever you do here is the definition. The problem, of course, is that if it is defined as a member function, it will cater to expressions like C1 plus 5, because the compiler will simply interpret it as C1 operator plus and then 5 as the operand. But if you write 5 plus C1, the compiler will simply give up. There's no way to match, because the first argument is basically the argument where the compiler is from where the compiler starts looking for operator definitions. So if the first argument is integer, then it becomes difficult. It doesn't mean that the compiler will give up straight away. The compiler does have a list of all the defined operator definitions, and it will try its best to match it to someone. So that is why in such cases what we do is we create two friend functions, one where c1 is the first where complex is the first operand and integer is the second operand. So let us take this example. So if you are defining it for c1 plus 5, this argument will become complex, this will become int, and then you also provide an overloaded form of this definition where int is the first parameter and complex is the second one. So this is the problem. Operator overloading, I'm not a fan of it because there are so many issues associated with it. And as I said, it becomes even more problematic when you are doing it, for example, for operators like plus plus, because the plus plus operator already has two different forms. If you put it before the operand, it is interpreted in a different fashion. If you put it after the operand, it is interpreted it in another fashion. So there are some ways to do that. I think you pass an integer as a different parameter to make an overloaded form. It's been very long since I dug up into the literature of operator overloading, but that is the idea. It's a very cryptic piece of C++ zone, and if you ask me, I will strongly suggest that you should not venture in that zone. Okay, try to use function overloading, method overloading to whatever extent is possible, but try to avoid operator overloading. Any other queries? Okay, then. So you guys had the lab yesterday, right? Or the other batch? I think the other batch had the lab. So the question is exactly the same because this is a practice lab. You can either borrow the question from the other batch friends, or I'll just pass on the same question to the TAs. The idea is not really to build the system in the question. The idea is to try to use your brain um, to sketch it. That is the idea, right? So because this is a practice lab, I want you guys um, to try out your inheritance skills or polymorphism skills. So whatever you've understood till now, how do you use the object oriented programming skills to actually create an application? So I think your lab will be on Friday. The question is exactly the same. You can have a look at the question already, or you can just say, okay, I'll just look at the question on the day of lab and I'll try to apply my mind for 2 hours. It's up to you. Okay, it's basically self discipline kind of thing. You have to see what is best. Okay, if there are no more queries, we can break. And again, keep in mind that you have the Friday deadline to provide your group group details. Okay. Okay, guys. Thank you then. Bye.
Thank you, sir.